Hello, everybody. Um, yeah, as Alex said, I'm Dominic. I've been working in human factors for about 15 years now. Some of that time has been in academia, working in healthcare, looking at the usability of medical devices in hospitals and things like that. A lot of my work nowadays is with the oil, gas, and chemical sector. And what I'll be talking about today is a methodology that we apply quite regularly there. But in this case, we'll be applying it to a pharmaceutical manufacturing process. So preparing an autoclave or a trolley for autoclave sterilization. But I'll describe just a little bit more about the details of the case study. And we will be going into a little bit of detail so you can see how the methodology is applied and what sort of results you can get out of it. But we're not really limited to the pharmaceutical manufacturing process. And indeed, bridging this methodology from the oil, gas and chemical sector, I think shows that it's more broadly applicable. And I think it's that you should find interesting. I'll just move on. So as Alex said, I've been working with the Pharmaceutical Special Interest Group at the Chartered Institute of Ergonomics and Human Factors. Julie Avery now chairs that. It's a great group. We have some really good discussions. And if you're in that general sort of sphere of interest, then please get in contact with us if you're interested to find out more and if you want to join it. I've got my details and Julie's details at the on the last slide, so you can find out more about it there. But the Chartered Institute of Ergonomics and Human Factors is also a great institute to find out more about this kind of work. This is a graphic from them, which I think shows sort of like the breadth of human factors and really taking that sort of systems perspective. Thinking about the different tools and equipment, the environment, the way tasks are organised, and how the way our bodies are composed, and how we think, and how that all comes together to impact performance. So before diving into the details of the case study, I just wanted to give a quick overview of this methodology, and then a quick overview of the task itself, and then we can go into some of the details. So, human factors critical task review. This is actually known by a few different names in different areas. In the process industries, it's more commonly known as safety critical task analysis. It's also known as SHERPA, from my boss David Embry's sort of paper in the 1980s. But principally, it's recognised for sort of three sort of core elements, if you like. The first is a deep and systematic task analysis of the task that you're looking at. So that's a number 2 there. Once you've got that detailed task analysis, you would then look at the potential for human failure. So 3 and 4. So there are a number of guide words and categories that are related to different activity types. So you can go through and you can explore the potential for different types of failure. Then once you recognise those different types of failure, then you would look at the factors that are driving that failure. So are the performance influencing factors organised in such a way that they are reducing the likelihood of that failure happening? Perhaps you've got some optimal conditions and you've got good practices in place and good design, and so there's not really much concern around that type of failure happening. Or are those performance influencing factors actually increasing the likelihood of failure? There might be poor labeling, poor lighting, poor usability of the equipment. and those things can interact and they can increase the likelihood of failure. So those three elements really provide the core of this. So we've got the task analysis, failure analysis, and then the PIF analysis, performance influencing factors analysis. Now, I just wanted to spend some time at that front end, number one. So I think that this is of interest, particularly if you're working within organizations. You might be, if you're interested in applying this approach, you might be interested in how this fits within a quality sort of improvement program. What you can do there is you can actually identify a range of tasks that you're worried about, and you can prioritize those tasks. That could include sort of like the criticality of those tasks. So what could lead to quite heavy losses for the company. That could either be from a safety perspective, or it could be from a quality and production perspective, in terms of time and money. And then you can prioritize those, and you can build up a program of work to look at these tasks sort of across a number of months or years, to gradually lead to a good evolution of human factors at your plant or site, and reduce the likelihood of errors happening. So we can identify the tasks we're interested in and prioritize those and create a program. Then for each one, we can then attend to it. We do a task analysis, failure analysis, and PIF analysis. And then at the back end, number 6 there, we're talking about improvements. So actually not just understanding, how to drive failure down, but trying to think about the different design interventions we can make so failure is less likely, thinking about procedural support. So what documentation are people relying on to do their jobs well? And then think about training interventions as well. So those 3 pillars we'll return to later in the talk. I will just stress at this stage as well that this is very much not a desktop exercise. We need to involve the people on the ground to, give us an idea as to what the problems are. And it's also good to observe the task in practice as well and have a walkthrough, so you can actually see some of the performance influencing factors at play. So that's an overview of the methodology that we're focused on here. The case study itself is an autoclave preparation. So the company that we worked with on this, they're a pharmaceutical manufacturer, and this particular task is to sterilize tools that can then be used to fill some syringes in a sterilized area. So what this involves is basically checking that the tools and instruments that they need are correct, clean and dry. Then they need to bag them up in a special way, and each tool requires different bagging. And then they place them on a certain configuration on a trolley, and then push that trolley into the autoclave. Now the autoclave, like very rudimentary understanding, is basically like a big oven that sterilizes everything in it. And this procedure needs to be followed quite carefully, because it's a validated procedure, and even something that isn't bagged correctly or in the wrong configuration on the trolley will invalidate that process, and it might have to be restarted. So that's the general overview of the case study that we're talking about. I'll just take a sip of my tea. Right, so what we did, we had sort of a day and a half to talk to the operators, and we spoke to 6 of them in pairs, and it was quite interesting talking to them about their work and what they were concerned about. And that was one of the first questions, really, was trying to get an idea about, what they're worried about, where they can see human failures occurring, what's happened in the past. Now, one of the observations at this early stage was that there was, I would say, a good awareness of what could go wrong, but it didn't appear to be that structured. When we were asking people, they were sort of trying to brainstorm and think about what was sort of top of mind for them. But it wasn't like they could list off, the top 5 things they're worried about or the top 10. And one of the good things about this method is that we can start to sort of extract some of those concerns in a more systematic way, articulate them and note them down. So the operators that are working on a task, they can have, a much clearer understanding of what the risks are when they're going to go about doing this task. And I think that has lots of advantages, that risk awareness, that's what we're promoting here. And that can come through, as we see later on, not only in more standardized training, but we can make risk-aware procedures. So having warnings and comments in the right place. And we can focus our quality improvement interventions on some of the highest risks that can be found here. Now, just to go over this briefly, so what they're worried about is residual water once it's gone through the autoclave. You can have wet loads and equipment that's not dry. If that happens, then it has to go back in again. There's quite a lot of equipment. I think there's about 21 different items, so it is possible for things to be forgotten or to get the wrong equipment. As I said before, there's particular bagging processes, so that needs to be followed carefully. There is potential for that to go wrong as well. Even the wrong orientation of some things in the bag can have an impact on the sterilized process area, because of the nature of the task, they're not allowed to handle all of the equipment. You might need tweezers and they can't touch certain parts, so the way the items are orientated really matters as well. And also, the orientation of stuff on the trolley. Now, each one of these examples of things going wrong is recoverable. They can just put the thing back through the autoclave and recover from it. It might cost them a couple of hours of time, so even that is quite significant. But if in that recovery load they have another one of these errors or something comes through wet, then they might lose the day, potentially about £40,000 worth of product, and so that's quite a big consequence for this sort of task. So we did the task analysis. I won't go into the detail. Normally they look a bit more different to this. They're not normally quite so flat and horizontal. But here we have the preparation of all the 21 different bits of kit for the trolley, and they work through them one by one following an appendix. After we'd done that, we went through and we tried to identify where the areas of concern were. And you can see here that we've got green bits of equipment where they're not really concerned about things happening, orange, which is sort of mild concern, and then red, where they really felt that there was an elevated level of concern. And so we focused our analysis on those particular areas. Now, this is just for illustrative purposes, but it does give you an idea of where the hotspots are and that understanding of risk. So to delve into the detail a little bit, so all of the items need to be double bagged, apart from these 3 things. So at steps 4.2, 4.3 and 4.8. So these things need to be triple bagged. And because of that, it can be, sometimes you can, you get in the habit of doing double bagging. And then when you come across something that needs to be triple bagged, you could miss that. So here we have the potential error, missed that it should be triple bagged. Then we've got performance influencing factors. that the procedure doesn't really emphasize as well as it could do that this is a triple bagging step. So some potential improvements there is we could improve the readability of the procedure, consider adding additional warning sign, and we could even, rather than having these triple bagging items spread out in that task, we could group them all together, so it's much easier not to miss that's triple bagging. Another example, these are stopper tubes, and it really matters what way round these go in the bags. And what has happened here is sometimes they can get them the wrong way round, and actually on the procedures, the picture that they follow is the wrong way round. So it's almost like an error trap, if you like. And that could lead to a slip error, where if you're not paying attention, you could put them in the wrong way round. And you can see at the bottom there's a little glimpse of the sort of analysis that we would do related to this step. We've got the task step number, the description, bag items in the inner bag, and then the size of the bag. We've introduced a warning there, which is in the current procedure. This is an action step. We could have the action in the wrong direction, which is the failure, the error description, and then the PIFs towards the ends there. It relates to the procedure, picturing the procedure being the wrong way around and the check not being as good as it could be. And then we've got the intervention potentially to just correct the orientation of the procedure. So relatively simple thing that could have big consequences. This is another nice one. It's a stopper transfer arm. So basically for this one, as part of the procedure, there's an arm there that you can see, and there's a disc, and it needs to be screwed in. Now, there is a right way and a wrong way to do that. So you could screw in the transfer arm on that side, which you don't want to do. And there's only a little indentation to tell you which way round it is. So you could get it wrong, and it makes the check hard to do as well. Now, potential improvements for this one could be a redesign of the assembly there, so you can only put it in the right way. So that would basically design out the error, and that would be, the best solution. Other things include adding a warning there, which there isn't in the procedure at the moment, and we could add an enhanced check as well. So here we have, again, really potential errors that have been identified. We've got different performance influencing factors that can make this more likely, and then we can think about improvements, different types of improvements to consider. Some are more costly and effective, others are quite cheap and could lead to the reduction in risk as well. This one is concern about water retention. We didn't have sort of specific improvements here, but we as just considering the risks here, it might be worth looking at in a bit more extra detail. You get the kind of idea for this methodology, so I won't go into all of these in a lot of detail. This stopper chute needs to be put in 2 big bags. This is quite a relatively larger bit of equipment. Now, 2 problems here is that some people would triple knot the bag, so it's hard to undo on the in the sterilized area, and they might also push the equipment too far down the bag, and then it could get stuck, and that also causes problems for people later on. So we can think here about more consistent training, making people aware of these issues, and then hopefully alleviating them going forward. An interesting one here is there's different types of bowl for different procedures. They look kind of the same, but there's an indicator of the size of them on the upper ring. Now, when the bowl cover is applied, that indicator is masked, so you can't see it. So a potential improvement here could be to have the sign actually at the bottom, so it's not covered, and so it's easier to see, and you can check there as well. So what we're looking at here really at the back end of this is sort of 3 pillars of intervention, if you like, and this goes for our work in process safety as well. But we're looking at design interventions, and these are the things I really like because they're, hopefully designing out and changing the environment and reducing the likelihood of error here. So these include things like the redesign of the transfer arm that I spoke about. So we're designing out that error. Also, the design of the signage on the bowl that I just referred to. So all of these things can help people in practice, and we're actually changing the environment there. Second pillar is procedural interventions. So looking at the procedures that people are actually following, and we can correct issues with them, like putting the picture the right way up. We can add additional warnings, so there's better risk awareness to do with those procedures. And we can redesign the task actually to make it more error-proof. So for example, putting all the triple bagging items all together, so they're less likely to be overlooked and forgotten. We've also got training aids to develop, so for more consistent training. At the moment, when we were talking to operators, there was a lot of on-the-job training, that, looking over someone's shoulder and getting mentored. But we heard also the potential for inconsistency there. And so something like this, where we can focus in on the critical task steps, we can recognize the knowledge that's required to do those task steps correctly. We can have the skills demonstration to do those task steps correctly, and then we can sign people off a bit more consistently. So we've got design interventions, procedural interventions, and training interventions there, all to support human performance.
2 minutes.
Great, thank you. Just near the end. So here we have our original top 10 hotspots. And this, just for illustrative purposes, if we took all of the recommendations on board and did the support, we could turn some of those reds into greens, we could turn some of the reds into oranges, and we can try and de-risk the process. So really, I think this methodology, we're looking at opening up conversations with staff in a structured way to find out what they're concerned about and how we can help. We're doing that in a very step-by-step basis, so it's very detailed, and getting to know more at work as done rather than work as imagined. So it's very much talking to staff. This is very risk informed, and that's what we're focusing on, the error hotspots and where we can have most impact in terms of supporting human performance. We can consider the psychology and design of things, so we can help design the environment and the context to be more effective. We've got risk-informed procedures and those training aids that I referred to. So thank you for listening. I've got Julie and I's details there. If you're interested in the special interest group, then get in touch with us to find out more and perhaps join. If you want to know more about this particular methodology, then we've got a free 30-minute mini course on the topic. But I'll leave you with that, and happy to take any questions. Thank you.
Thanks very much, Dominic. First question is from Lee Fairbairn, and it's fairly detailed, so I might read it twice. What balance of review of critical tasks at the design stage of a process, i.e. proactive human factors knowledge involvement, versus review of operational tasks to resolve problems, i.e. reactive engagement of human factors practitioners and specialists, do you see in industry practice? Does it differ across different sectors in your experience? I'll publish that so you can see it, and it might, should come up in the answers questions.
Thanks for your question, Ollie. The difference between proactive and reactive. So proactive, before you've experienced the problems, we can have a look at this and try and recognize those vulnerabilities and correct them. Reactive is where something bad might have already occurred. we can actually have proactive and reactive sort of within operations, so outside of the design space. So before anything's happened, we can go in and have a look and sort out the vulnerabilities. But when something bad goes wrong, obviously people get more interested in how it's gone wrong and the human factors there. So there's opportunity there. You can apply this in a design context as well. So before you've created the line and the plant, you could do the task analysis at a high level, and then gradually, as the design unfolds, you can detail that out and try and recognize some of the requirements and risks involved in a design context. So in terms of this differing between sectors, very much so. So in the process industries, particularly to do with the COMA regulations in the UK, so the control of major accident hazards, this sort of stuff for the most critical tasks on a plant, which could lead to multiple fatalities and bigger environmental disasters. The regulations require COMA sites to look at proactive human factors. And so there's a requirement there for COMA sites to do that. Now, in the pharmaceutical sector, there's not that drive and there's not those requirements. And so this is something we're exploring with pharmaceutical sites to promote sort of quality improvement. And so you're getting those gains in quality and production a bit more. So I think there's a lot to be gained there. But yeah, it's a journey, I think, and there's different sectors are in different places.
Thank you. Next question from Karishma Kamani. She says, thanks for sharing the HFCTR methodology, Dominic. I'd like to know whether this methodology uses a set of predefined error modes denoting the particular form of action or thought in which an erroneous action can occur by a human, e.g. action at the wrong time, action on incorrect object, etc.
Yeah, very much so. So when we do the task analysis, we break it down into individual task steps. So at the bottom level of the breakdown, we might have things that are checks. So check that the item is bagged correctly. We might have actions. So put the stopper tubes in the bag the right way around. We might have monitoring steps. So check the autoclave is at such and such a temperature. Now, each one of those is a different type of activity type. So one's a check, one's an action, and one's a monitoring task. And there's various other ones as well. Now, we've got a library within the software that we use that has different failure modes associated with each activity type. So you could have check omitted, check incomplete, check too soon or too late. And so you can select which failure modes are relevant. You can also associate, I'm getting a bit detailed here, but the psychology that's going on behind this. So whether it's just an attentional error, or whether it's a knowledge-based error, or whether it's a decision error, like an issue of non-compliance. And then each one of those, we can then look at the PIFs of what's going on there. So what's driving the errors or reducing the likelihood of them. So there's very much a library of these things, and there are published lists of these things that you can look at for free. If you look at failure mode lists and also performance influencing factor lists or performance shaping factor lists, I think they're on the Health and Safety Executive's website. If you're interested, or get in touch with me and I can send you stuff as well.
Thank you very much.